Hello everyone, welcome to Sampada's Learning Hub, your place for easy and clear science learning. Today we are starting our General Organic Chemistry series with an important topic, homolytic and heterolytic cleavage. We'll discuss what these terms mean and the conditions under which they occur and give examples to help you understand better. Okay, we are going to see the homolytic and heterolytic cleavage. First of all, we'll see what is the definition of homolytic cleavage. Homolytic cleavage is the process in which a covalent bond breaks evenly with each bonded atom receiving one electron from the shared pair. Means what? For example, ये दो atoms है, okay, C and A, and in between that covalent bond is there with the two electron. जब ये bond हम break करेंगे तो एक इलेक्ट्रॉन ए को मिल जाएगा और दूसरा इलेक्ट्रॉन सी को मिल जाएगा एंड वी आर गेटिंग द प्रोडक्ट द रेडिकल सी एंड द रेडिकल ए. वी कॉल्ड इट द फ्री रेडिकल. ओके, we'll see the examples of homolytic cleavage. The first one is chlorine molecules, that is Cl2. okay, and another condition is UV light. Then Cl2, we can also write this Cl and Cl. Okay, then under the condition of UV light, what we'll get, this bond will break, and the one electron will get this chlorine and another electron will get this chlorine, so we'll get the chlorine radical and this one is another chlorine radical. Okay, this is the first example. Then we can take another example is hydrogen peroxide. Hydrogen peroxide H2O2. So the condition is upon the heating and the UV light. Okay, so we'll write here H2O2, that is hydrogen peroxide. Similarly, we'll get two radicals, that is OH radical and another one is also OH radical. Okay, then the third example is methane, that is CH4. So this is under the condition of high energy. Okay, so you can see CH4 here, heat is there. Okay, CH4 under the condition of, what we'll get, the radical CH3 and the another one is H radical. Okay, then what we can see, the fourth example is bromine molecule. Bromine molecule, that is Br2. Okay, under the condition of light you can say Br2, what will get, Br radical and another one is Br radical. Okay, so we'll see, so these all are the examples of homolytic cleavage. Now we'll see in which conditions this homolytic cleavage happen. So the first condition is symmetrical bond. Symmetrical bond. Whenever symmetrical bond is there, the homolytic cleavage happen. जब भी symmetrical bond होगा दोनों कोई भी दो एटम में, तो वहाँ पे homolytic cleavage होगा. Then the second one is high temperature. The second one is high temperature. Then third condition is when photon is present, the homolytic cleavage occur. Photon presence. And the fourth condition is when non-polar solvent is present, the homolytic cleavage occur. Non-polar solvent. Got it? So these all are the conditions. Whenever these conditions happen, then only the homolytic, this all are the condition is present, then only homolytic cleavage occur. Okay. Then we are going to see the application of homolytic cleavage. Okay. We'll see. Application of homolytic cleavage. So the first application is free radical polymerization. Free radical polymerization. And the another application is the halogenation of alkane. Okay, already we halogenation of alkanes. For example, chlorination of methane. Chlorination of methane. So this is how our homolytic cleavage is over. Okay, now we are going to see heterolytic cleavage. Okay, so what is meant by heterolytic cleavage? Okay, dear students, now we are going to see heterolytic cleavage. It is also called heterolysis. Like already we have seen homolytic cleavage, and that time also I told you the homolytic cleavage is also called as homolysis. Similarly, heterolytic cleavage is called heterolysis. Okay, now what is the definition of heterolytic cleavage? The heterolytic cleavage is the process in which a covalent bond breaks unevenly with one atom taking both electrons from the shared pair. Means what? For example, these are the two atoms. Okay, ये दो atoms है C and A, और whenever these two atoms, these two electrons are taken by A, will get two radicals because C के पास अभी कोई भी इलेक्ट्रॉन नहीं बचा है. So that is why they are getting plus charge and A are getting two electrons. A getting two electrons. That is why it has the negative charge. Okay, तो जिस एटम के पास कोई भी इलेक्ट्रॉन नहीं होता है, कोई भी इलेक्ट्रॉन उसे नहीं मिलता है, बॉन्ड दिस कोवेलेंट, ये कोवेलेंट बॉन्ड ब्रेक होने के बाद, तो वहाँ पे पॉजिटिव चार्ज आएगा, और जहाँ पर ये जो एटम है उसे दोनों भी इलेक्ट्रॉन मिल रहे हैं, इसीलिए वहाँ पे नेगेटिव चार्ज आएगा. ओके, एंड दिस पॉजिटिव चार्ज ऑफ द कार्बन इज कॉल्ड कार्बोकैटायन. हम इसको क्या कहेंगे? कार्बोकैटायन. इट इज ऑल्सो कॉल्ड एज कार्बोनियम आयन. हम इसको कार्बोनियम आयन भी कह सकते हैं. कार्बोनियम आयन. ओके, now this is the first condition. Now another condition is, again, if these two electrons taken by C, अगर ये दो इलेक्ट्रॉन C ले लेता है, तो सिमिलरली यहाँ पे C के पास क्या आ जाएगा? नेगेटिव चार्ज आ जाएगा और ए के पास आएगा पॉजिटिव चार्ज, बिकॉज ए के पास कोई भी इलेक्ट्रॉन अभी नहीं है, दोनों भी इलेक्ट्रॉन सी ने ले लिए, इसीलिए यहाँ पे इसे निगेटिव चार्ज मिला है। तो हम इसे क्या कहेंगे, कार्बनियन। जब भी मैंने वह कार्बन एटम पे निगेटिव चार्ज होता है तो हम उसे क्या कहेंगे, कार्बनियन। कार्बनियन, ओके। Now we'll see the conditions when this homolytic cleavages occur. What are the, in which condition this in which condition this heterolytic cleavage happen? So we'll see. The first condition is whenever the electronegativity difference is there, okay. Whenever electronegativity difference is there, then heterolytic cleavage happen. The second condition is whenever low temperature is there, okay. Low temperature is there. जब भी low temperature होगा तब heterolytic cleavage will occur. Then the third condition is whenever polar solvent is present, the heterolytic cleavage is happen, okay. Now we are going to see the examples of heterolytic cleavage. Examples of heterolytic cleavage, okay. We'll see the first example, the hydrogen chloride, okay. We'll see hydrogen chloride. In the presence of water, what you will get, H plus. In the presence of water, what you will get, H plus and Cl minus, okay. Then the another example is, we'll take alkyl halide, means CH3Br. In the presence of polar solvent, what you will get, CH3 plus Br minus, okay. Then you can take the third example is sulfuric acid. In the presence of aqueous solution, H2SO4, what you will get, H plus plus HSO4 minus. Then the fourth example we can take the acetic acid, means CH3COOH, what you will get, CH3COO minus plus H plus, okay. And another example you can take is nitroalkane, means RNO2, what you will get here, R plus plus NO2 minus. Got it? These all are the examples of heterolytic cleavage. So here in each example we have seen we are getting two ions, that is H plus Cl minus CH3 plus Br minus, okay. Similarly we have seen another examples. So we are going to see the applications of heterolytic cleavage. We'll see applications. Now what is the first application? This heterolytic cleavage is happened in organic reactions such as nucleophilic substitution, then another one is elimination reaction, and electrophilic addition. Electrophilic additions. And what is the another application is? The second application is the formation of carbocations and the carbanions. The formation of carbocations and carbanions in the reaction mechanisms. Got it? So this is how we have completed heterolytic cleavage. Okay dear, today we are going to see the difference between heterolytic and homolytic cleavage. So now we are going to see some conditions for each homolytic and heterolytic. The first condition is energy requirement. Energy requirement. So for homolytic cleavage, it requires high energy like UV light and heat. Okay, and for heterolytic cleavage require low energy or mild conditions. Then the second condition is solvent type. So it's required for homolytic cleavage require non-polar solvents, and for the heterolytic cleavage require polar solvent. Okay, then the third condition is bond type. So in homolytic cleavage there is a symmetrical bonds. For example, Cl, Br, bromine. Okay, then here polar bonds present in the heterolytic cleavage like CCl and CBr. Got it? Then the fourth condition is catalysis. It's required. The homolytic cleavage is occur in the presence of radical initiators. It is means peroxides. Okay, means peroxides. Then here is the heterolytic cleavage is required. Which condition of which catalysis? That is acidic or basic catalysis. Got it? Then the another condition is, fifth one is resulting species. What we are getting in homolytic cleavage is free radical. free radicals. And in the heterolytic cleavage, what we are getting? Ions. What we are getting? Ions, that is cations, that is cation and cations and anions. Okay, so dear student, these are the difference between the heterolytic and homolytic cleavage. If you found this video helpful, give it a thumbs up and subscribe to Sampada's Learning Hub for more science videos, and don't forget to comment below if you have any question.